Do we need to set science free? And what does it even mean? Who is a captor of science? And how do you distinguish a bad science from good science? Hi, my name is Rועי, and welcome to my channel where I host the most interesting and influencing people and scholars from all around the world to discuss science, religion, philosophy, artificial intelligence, and even more. And my guest today is Dr. Rupert Sheldrake. If you don't know the name, so first, shame on you. He is a biologist and the author of more than 80 technical papers. He gave the famous banned TED Talk, a brilliant TED Talk that was banned by TED. He is the author of The Science Delusion, or in the US, another name, Science Set Free, and Science and Spiritual Practices, and other books as well. He is also the originator of the Morphic Resonance theory, and he was a close friend with the late Terence Mckenna. So, Dr. Rupert, thank you so much for coming today. It's a true honor to have you on the show. How are you?
I'm fine. It's good to be with you, Roy.
Okay, thank you so much for coming. So I think that we should start at the beginning, and the most important word regarding your impressive work is scientism. Now, put it simply, it is a blind belief in science, and Richard Dawkins himself said that this is a dirty word. Now, you have two names for your book, one Science Set Free, and the other is a Science Delusion, and I think that it is that the delusion is very close to what we call scientism. So first, what scientism is, and second, if science has brought us so far, why is it bad to believe in science?
Well, I think it's good to believe in science. I'm a scientist. I've spent my whole career doing scientific research, and I'm still very busy, writing scientific papers and doing experiments. So I'm totally pro-science. But it's precisely because I'm pro-science that I'm worried about the dogmatic attitudes that have become associated with it. From the late 19th century onwards, the implicit and sometimes explicit official orthodoxy of science has been materialism. And materialism is the philosophy, as you know, that matter or physical reality is the only reality. The universe is unconscious, everything's unconscious and mechanical, governed by purposeless laws. Evolution is purposeless. Our minds are nothing but the activity of our brains. So this is the materialist worldview. It's a philosophy rather than science, and it's based on a whole series of assumptions. And these have become the assumptions from which scientists work. The mind is nothing but the brain. So virtually the whole of cognitive science, academic psychology, and neuroscience is based on this assumption. The world is mechanical rather than organic. Again, this is the foundation of so much of scientific research. And what I would say is that these are restrictive assumptions. They're not scientific facts, which many people think they are. They're simply assumptions. And scientism is a worldview based on these assumptions of materialism that treats them as if they're established truths. As a scientist, what I do in my book, Science Set Free, or The Science Delusion, is take the 10 dogmas, the 10 most common and prevalent dogmas of science, and turn them into questions and see if we treat them as hypotheses rather than assumptions, how well do they turn out in the light of scientific evidence. So it's really an attempt to look at the foundations of science and see whether they could be different. And if they are different, then whole new areas of potential research open up.
Okay, so let me just see if I got it correctly. There is a difference between dogmatism and scientism because the scientific world has a tendency to push back dissenting ideas. Science is not pluralistic by nature and it has an orthodox view. And of course, it was Max Planck who said that a new scientific truth doesn't triumph by convincing its opponent and making them see the light, but rather because its opponent eventually die and the new generation grows up that are familiar with it. So basically, the science is dogmatic, and this is part, and this might be something inherent in science, but scientism is just to take the materialistic worldview to the extreme and say, I cannot, and I'm not willing even to discuss any other scientific alternative. Is this correct?
Yes, it's a good summary. And scientism is actually not what most scientists believe. Most practicing scientists are just getting on with the job in a specialized area of science. They're not educated in the philosophy of science, mostly. I mean, for example, in Cambridge, which does have a philosophy of science course, only about 25% of natural science students study philosophy of science. In many universities, even less. So most scientists don't know much about the philosophy or the history of science. They're specialized in a particular area, solving puzzles within a framework set by their subspeciality. The ones who speak loudly about the scientistic worldview, the materialist worldview, are mostly popularizers like Richard Dawkins, who propagate this scientistic worldview. And many of the believers in scientism that I come across are not scientists and don't actually know much about science, but they're completely convinced it's science rather than religion that provides the way forward. So it's usually associated with atheism and often with militant atheism.
Okay, so I want to take one point from what you just said, regarding nature being purposeless. And I teach Maimonides in Israel, and Maimonides is heavily relied on the thinking of Aristotle. And Aristotle described 4 different reasons. One is the reason with purpose. Why does the plant grow? You want to fulfill its purpose. But ever since, and I think that this is a correct observation, science has abandoned the concept of purpose, the concept of meaning in its inquiries. Science began to triumph because interleaving or set purpose inside the scientific world will get you to the philosophy of Aristotle or the physics of Aristotle. So maybe the idea that nature is purposeless is a good policy to propagate science. What do you think?
Well, in the 17th century scientific revolution, the mechanistic revolution, when there was a shift in Europe from the idea of nature as organic, medieval Christian theology was based on Aristotle largely, and it had the idea that there are purposes inherent in all living organisms, and that nature is organic, so what would now be called panpsychist or animistic. The 17th century revolution abandoned the idea that there are souls or purposes in nature and said everything's just mechanical, based on pushing and pulling and mechanical causes. Well, that's pretty good if you're studying mechanical causes. And mechanistic science is best when it comes to machines, which is its principal metaphor, and leaves out purpose. And the classic paradigm of mechanistic science is billiard ball atoms colliding with each other.
Yes.
But if you think about the actual metaphor, billiard balls are part of billiards, and billiards is a game, and people who play the game of billiards have a purpose. They want to win. People who make billiard balls and billiard tables and sell them are serving a purpose. It's all purposive behavior. So these billiard balls are within a highly purposive environment, and it's a kind of abstraction to remove the purpose from them. In the case of animals and plants and humans, whose behavior is clearly purposive, they move towards ends or goals. Biologists undergo an extraordinary mental contortion because they have to pretend that they have no purposes, and then they have to reinvent the purposes under different names like teleonomy instead of teleology, and smuggle in purposes. For example, Richard Dawkins' concept of selfish genes gives purposes to the genes. They're selfish, they want to get ahead, compete
Just a
with
second,
others.
give human attribute. Selfish is a human attribute, and it's like a human character, and we attribute it to a consciousless thing, a gene. How a gene could be selfish. It was also raised by the late Roger Scruton, the famous conservative philosopher, which is a great point.
Yes, exactly. You see, my point about my criticism of people like Dawkins and Daniel Dennett, who's a materialist philosopher of mind, is not that they're mechanistic, but that they're crypto-vitalist. What the selfish gene introduces the purposive vital factors of vitalism, projects them onto molecules, and then says that they're actually purposive and have these goals. The idea of the genetic program does very much the same. A program for a computer is intelligently designed to carry out purposes. And so saying the genes constitute a genetic program is again smuggling purposes in. And when someone like Daniel Dennett compares the mind to the software running the hardware of the brain, then again, the software is in a computer is purposive. People don't write random programs that do random things. They write programs to do useful things, to fulfill purposes. So actually, it's impossible to avoid purpose. And I think it's much better to acknowledge it openly, frankly, and honestly, rather than pretend it's not there and then smuggle it in and use it cryptically. Daniel Dennett says that we need the concept of purpose to understand living organisms, but it's not really purpose, it's as if they're purposeful. Well, why say it's as if when actually they are? So I think in practice, modern mechanistic thinking is very teleological. It's just that it pretends not to be.
Okay, so basically, when we abandoned the purpose aspect of physics, and it was fine, and it let physics triumph because of the mechanical aspect, and once the mechanical aspect was completed in the late 20s of the 20s or the 20th century, it was done. But when we moved to like advanced physics, so this purposeless, I think, in many cases is insufficient. And many people say this is why we haven't seen a huge progress in physics in the last 40 or 50 years. So I would go from here to like the implication of your theory, because some people say, you know, those thinking pathway leads to bad science. And my question is, how do you distinguish bad science for good science? Because, for example, regarding the COVID, we have many people on the internet say that this is a fake. This is not a pandemic. This is like the Israeli conspiracy and the Vatican conspiracy. You received such an email recently, and this day we have the climate conference in Glasgow. So if there is an inherent difference, in your opinion, between people saying COVID doesn't exist and people say, listen, global warming is a fraud?
Well, personally, I'm neither a COVID denier nor a climate change denier, and I take a rather conventional scientific view on both these issues. I think the evidence is quite clear. I mean, I think science is about evidence. And I think that the evidence for COVID actually existing, I mean, 5 million people have now died of something. I suppose those who say deny COVID say have died of something else, not COVID, but they've died of something. That's an undeniable fact. There seems to be good evidence that vaccines actually work. They may have some dangers. I've been vaccinated 3 times now because I think the risk of the vaccine is much less than the risk of actually catching the disease. So, and climate change seems to me, it's clearly happening. There can be some argument about how much is because of carbon dioxide or methane or changes in solar activity, but it seems to me it's clear it's happening and that we've got something to do with it. I see all that as reasonable, good science because it's amply backed up by evidence. Now, there are some kinds of scientific claims which I think are bad science because they're not backed up by evidence. And one example of bad science, I think, is the attitude of so-called skeptics to psychic phenomena like telepathy. Many so-called skeptics say there's no evidence for these, they don't exist, they're impossible, and anyone who works on them or thinks about them is a pseudo-scientist. The interesting thing about people who say that is they don't look at the evidence. I've had debates with most of the psi deniers, and the thing that they have in common is that they're utterly ignorant of the evidence. They think there's no need to look at it because they already know the truth. And this is, I think, a very good touchstone for bad science, people who think they already know the answers and don't need to look at the evidence.
So please let me just explain what are you meaning, because I think that this is mind-blowing. You said many people feel or report that when they think of a close friend, he usually phone them. And then we say usually, it's merely statistic. You know, you think about your friend many times and most of the time he doesn't call. So once in a while, and this coincidence seems wonderful. But then you say, guys, but we can conduct an experiment to measure this. We can conduct an experiment that measure this thing. And if we measure these things, and you have done several of these experiments, you said with 4 people that you need to guess which one of your 4 friends are calling you, and you say out of mere statistic, you need to be right approximately 25% of the time, 1 out of 4. But when you did the experiment, the ratio was approximately 50%, yes?
Yes, about 45%, yes.
So this is when you have a large enough sample, you cannot ignore this. Please help me explain what the facts are, because the facts doesn't correlate with your theory that this is mere statistic, because mere statistic will give me 25%. I'm more than almost double, yes?
Yes. Yes, well, you see, this is a good example, actually, because how I start my research is I collect stories from people. I have a huge database, about 12,000 stories of unexplained human and animal behavior. So I look at the natural history of what people claim, what they say has happened to them. And lots of people say they've had this experience with telephones, for example, that they often think is telepathic. Well, since the invention of the telephone, this has been going on for well over 100 years. And for 100 years, skeptics said exactly what you say. Well, you think of people all the time. Occasionally one of them rings. You forget all the times you're wrong. For 100 years, that skeptical armchair argument was accepted by so-called scientists or scientific skeptics without a shred of evidence. When I first got interested in this, I asked people who said that, have you got any evidence? How many times do people think about their friends and how often do they ring? Where are the statistics? They had no evidence whatsoever. It was purely a theoretical argument. It's a reasonable hypothesis. So I decided to test it. And that's why I did these experiments where we have it during a fixed experimental period. The subject sits at home with a landline phone, no caller ID. They have 4 callers, people they know well. We pick the caller at random and ring them and ask them to ring their friend. When the phone rings, they have to answer. They're being filmed before they pick it up. And that experiment gives a 45% with hundreds of trials, a highly significant positive result. So this is a way of actually testing. And until I did these experiments, no one had done any experiments at all on this subject. And yet the so-called skeptics confidently dismissed the whole phenomenon. And one of their leading hitmen, the late James Randi, even awarded me the James Randi Wooden Spoon Prize for Stupid Science for doing this research, saying that he'd never heard of such a stupid idea as testing an obviously non-existent phenomenon, and that I should be subject to public ridicule for investigating it. Well,
now, if you just a second, if you're not familiar with James Randi is the originator of the JREF prize, where he promised $1 million for anyone who can prove some sort of supernatural abilities. So this is, and he began his career with a confront with Uri Geller, and Uri Geller, let me give you the other side, because I myself practice mind reading, telepathy as a mentalist. Okay, so the other side, and I think that Randy's argument is going like this: when you say that a mind reader, clairvoyance, whatever, yes, like a psychic, is being tested, and he's being tested by scientists. So since your background is biology, you look at Petri dish and you say, okay, when do I see some germs in the Petri dish, yes or no? So the answer is either yes or no. But when you test a psychic, there are two possible outcomes. Either is real, either is genuine, and this is great, or is fraud. But if he is lying, he will try to mess your experiment. And this is not the case with the Petri dish, because he is basically a hustler. And what James Randi said, scientists don't work usually with hustlers. They don't have the tools. We, as magicians, we have the tools to catch hustlers. What do you think about this argument?
I think it's perfectly reasonable if you're dealing with hustlers. If you're dealing with people who make their living by entertainment and on the stage and so on, then, everyone knows that magicians, mind readers are doing it through various forms of tricks. But it's precisely for that reason that I've concentrated not on stage magicians or professional psychics, but on totally ordinary people, and who have no motive for cheating. I mean, they're not getting any money out of claiming to be telepathic with telephone calls. I mean, 85% of the population say they've had this experience. We're not talking about a tiny minority of professional psychics or clairvoyants or stage magicians. We're talking about normal people. So I've done all my experiments with perfectly normal people, and we tested them under conditions where they're filmed in rooms with no other telephone or computer present, where the possibility of cheating is virtually ruled out. And I've also done experiments on the sense of being stared at, which 95% of people say.
Wow, this is a great research. This is great research. I always think about it when I'm staring at someone. I say, oh, Sheldrick says that he can feel me right now. This is great. This is great stuff. I use it all the time.
Well, you see, that research on the sense of being stared at, again, is an extremely common phenomenon. Most children and adults all over the world have experienced it. And for 100 years or more, most believers in scientism have just brushed it aside. It's superstition, illusion, coincidence. You turn around, you only remember the time someone's looking at you, etc. Well, there have now been tons of experiments on this which show it really exists, which is no surprise to most people. And there again, Randy's argument doesn't really apply. These are not people who are trying to make a living out of pretending to be sensitive to stares. These are just normal people. And I've also done research on dogs that know when their owners are coming home. As you know, I wrote a book with that title.
Yes, definitely.
And many people, about 50% of dog owners have dogs that seem to anticipate the arrival of a member of the family. They wait at a door or a window. And we did experiments there. Again, the standard skeptical argument is they're going to the window all the time, or it just happens when they at a routine time when the person comes home, or they hear the car wheel drawing, the cars drawing up a familiar car engine outside the house. But in the experiments we've done, we have dogs that do this at least 15 minutes in advance. We have the people go at least 8 kilometers away, where they come home at randomly chosen times that we pick. They come in unfamiliar vehicles, and the dogs still do it over and over again. Now, again, the Randy argument doesn't really apply there. These dogs are not making a living out of being psychic dogs. They're just normal dogs that belong to normal people. So I think his arguments are perfectly valid when dealing with people who are professional miracle workers or claim to affect, stage, basically media type people. But I've deliberately focused my research on ordinary claims of ordinary people. And so when the skeptics say extraordinary claims demand extraordinary evidence, my answer to that is these are not extraordinary claims. 95% of people claim to have felt they're being stared at from behind. It's an ordinary claim.
Okay.
And it's the skeptics who are making the extraordinary claim. They're saying that 95% of the population are mistaken about their own experience. And they claim to know they're mistaken on theoretical grounds without any empirical investigation at all. So there's no extraordinary evidence for their point of view.
Just a second. And when you try to publish this like phone guessing experiment, you get rejected, you get major changes, or the scientific literature accept this and listen, they let you publish it because Harvard physics professor, Professor Avi Leib, the author of Extraterrestrial, was here on the show recently. And he said that his article regarding this giant asteroid Oumuamua was basically an extraterrestrial was accepted in 3 days. And this is a very unorthodox theory that an extraterrestrial from a very intelligent culture approached Earth. And it was accepted in 3 days. So what is your argument? Does it hard or impossible to publish those kinds of things? Or as Professor Avi Leib said, I published it in 3 days.
Well, it depends which journal. You see, there's a very strong taboo against psychic phenomena, probably much stronger than the taboo against intelligent life on other planets.
This was Avi Leib published his first article in Scientific American. Now, it's not Nature, it's not Science, but still, it's not an unheard journal.
No. Well, in my own case, for example, when I did my research on dogs that know when their owners are coming home, I submitted it to one of the leading journals in animal behavior research called Animal Behavior. And I got a letter back from the editor within 2 or 3 days saying no reviewer for this journal would consider any paper that mentions the word telepathy, and I'm therefore rejecting your paper without review. So I then sent it to the Journal of Scientific Exploration, which is a journal that deals with open-minded exploration of unsolved scientific problems. And I went through peer review and it was published. So there are many scientific journals, and if you don't get something accepted by one, I've published over 90 scientific papers in peer-reviewed journals. So you can do this, but you'd never get a paper on telepathy under present conditions in Nature or Science, or Scientific American, where Michael Shermer, who's I think one of the perfect example of a dogmatic skeptic, writes the so-called skeptic column, unpeer-reviewed skeptic column.
Up until recently, I was sure that you're correct, but then we had Michael Shermer had on his podcast, he had Stephen Meyer, and they discussed intelligent design, and they didn't debate, they just discussed those ideas. And maybe Michael Shermer rethink his whole life again, but something do happens. And when I spoke with Michael Shermer, he said that there is a tendency to go back to religious thinking, mainly because Jordan Peterson and many other, and maybe in 2 to 3 to 10 years, those things will be much more common. Now, let's move on with your permission, because we don't have much time and you are so full with great stuff, to morphic resonance. Now, morphic resonance is a big theory and we are not going to cover it in depth, but basically what you say that nature, how can I put it simply, that nature is not an unconscious thing, that it has, for example, like a unified memory of nature. And you have a great example with crystalline, how you can crystallize certain substance. So if you could please elaborate on the crystallization process or the crystallization experiment, and then we can move on to my question.
All right. Well, morphic resonance says there's a kind of memory inherent in nature, and each kind of self-organizing system has a sort of collective memory based on similar systems in the past. So each species of animal and plant has a kind of collective memory. This applies to crystals as well. So if you make a new chemical for the first time and you crystallize it, there's no existing pattern for the lattice structure of the crystal. And the conventional assumption is that it should crystallize the same way the first time and the millionth time and the billionth time, because it's governed by the eternal laws of nature, thermodynamics, electromagnetism, quantum theory, etc. According to the morphic resonance idea, the first time it crystallizes, you may have to wait quite a long time because a new field has to come into being. We don't know how new things happen, but they do happen. And once it's crystallized, it should be easier to crystallize it anywhere else in the world. And the more often you do it, the easier it should get. Now, it's actually well known to chemists that this happens. And it's been known for a long, long time that this happens. But they've always explained it in a different way. They say, well, this is because fragments of previous crystals get carried from lab to lab on the beards of migrant chemists, or else they're wafted through the atmosphere as invisible dust particles and settle out in labs all around the world. Well, to test this, you can just exclude bearded migrant chemists or any migrant chemists and filter out dust particles. And what I'm saying is they should still crystallize faster. So this is a testable, easily testable phenomenon. It also applies to animal behavior. If you train rats to learn a new trick in London, rats should learn it quicker in New York and Melbourne.
And there is not rat dust from the UK to Australia. So how this rat thing that a rat or cats can learn a new trick much faster in different continents can be explained in the conventional way?
Well, it isn't explained in the conventional way. Well, except the usual explanation would be, well, the scientists themselves get better at doing the experiments. And of course, that's something that can take place. But in the case of experiments with rats, which have actually been done at Harvard, the University of Edinburgh, and Melbourne, Australia, when they found that the rats were actually learning quicker and that it wasn't just rats descended from trained parents, but all the rats of that breed, people just said, well, you know, it's not Lamarckian inheritance, which is why they were doing the experiments, what would now be called epigenetic inheritance. And they said, we've proved it's not Lamarckian inheritance. That was what they wanted to prove. And so they just stopped there and everyone said, oh, well, good thing it's not Lamarckian inheritance. But the phenomenon itself was simply unexplained. And
yeah, it is not Lamarckian, but it is much bigger. Let me just give you something from the Jewish tradition. There is a very famous saying that I think stressing your theory regarding morphic resonance from Jewish tradition. And it goes like this. In the 16th century, there was a famous rabbi, Rabbi Joseph Karl, and he was thinking very hard for like several weeks on a new idea, a new construct in Judaism. And finally, after several weeks, he managed to conceptualize the new idea. And he came to the synagogue and he see like a young rabbi citing this very new idea. And he was very depressed that it took him so long, several weeks, and this young person just got it instantly. So he went to his rabbi, and his rabbi, Rabbi Luya, he was a famous in the Kabbalah, said, listen, you just took this idea and got it to earth and got it down. And when it is on earth, it is much easier for other person to access it. So I think that is like morphic resonance from the Jewish tradition. It is a very famous story. And when I encounter your morphic resonance theory, it's just, wow, this is basically the same. When you have this idea, like independent inventions from all around the world, like in the same times, many people from all around the world invent the same thing. But my question regarding your theory, regarding morphic resonance is twofold. Why? If it is a scientific theory, according to Popper, what needs to be done in order to say, no, this is a false theory? This is one. And two, let's say that I'm a young scientist. I want to publish as much as I can. And what you say are mind-blowing. So how come not more scientists pushing in this vector, which is basically mind-staggering?
Well, I'll deal with the second one first. When my book, A New Science of Life, was published in 1981, when I first proposed the idea of morphic resonance, I was trying to open up new lines of inquiry and research. I proposed a whole range of experiments in chemistry and biology, primarily, and psychology. And when the book first came out, the first few months, there was a really engaged and interesting discussion. And I gave seminars in universities, and there was a lively debate. And it was just what I hoped for. Then, after 3 or 4 months, an editorial appeared on the front page of Nature by the editor of Nature, Sir John Maddox, called A Book for Burning. And he proclaimed that he compared my book unfavorably with Mein Kampf by Hitler. And then said that this book was, that it was pure heresy, what I was saying, and that it shouldn't be taken seriously. And basically, he excommunicated me, or tried to, from the scientific world. And it meant that I couldn't get a job and I couldn't get grants from thereafter, and I was dangerous to know. And ever since then, whenever I'm invited to give a talk at a university, there's always some, even now, there's some kind of backlash where some people who are believers, usually scientific materialists, say that I shouldn't be allowed to give this talk because it's heresy and it will corrupt the minds of the young. And they try and get me disinvited. Sometimes I am disinvited. And the banning of my 2013 TED Talk on the science delusion was an example of that kind of thing. So many graduate students write to me. I have several a week from students, emails saying they'd like to do research on morphic resonance. But what invariably happens is that their PhD supervisors or potential supervisors say to them, well, some of them are open-minded. Some say, well, personally, I'm interested in this and I think it's a valid course of inquiry, but I advise you not to do it because if you do, you'll destroy your career before it's even begun. So right now it's treated as heresy, and anyone who does research on it is labeled a heretic or won't get grants or jobs. People are terrified of being deprived of jobs and grants because science is not very pluralistic, as you said at the beginning, and it's extraordinarily intolerant of what's branded as heresy. Now, coming to the first part of the question, when Karl Popper said that scientific theories should be refutable, it was a kind of logical point he was making. In practice, he later said, when you've got a new theory, it's more important to have positive evidence that makes people take the theory seriously enough to think it's worth refuting. So with a new theory, you look for positive evidence. And the experiments I've been proposing are ones which, if morphic resonance exists, would show that it does exist. But if you want to pursue the refutation point, then you could say, well, in relation to crystals, the standard theory is that they should crystallize the same way the first time, the millionth, and the billionth time, because the laws of nature are fixed. Now, doing this experiment would enable us to refute the conventional theory. Because they don't behave that way, it would help to refute the conventional theory. Well, nobody's very interested in refuting conventional theories, as I've discovered. They're only interested in defending them. So when defenders of orthodox science use the refutation argument of Popper. They use it as a stick to beat any new theory with, but they never apply it to their own.
This is a very interesting thing, that although the refutation argument is a very important one, and any scientific theory should have a refutation backdoor, first we need to just strengthen our theory and find positive evidence that it does work, because then people will take it seriously. This is very important, and I didn't think about it so far. So this is a very important point. Now, in the new edition of Science Set Free, on the cover there is with new experiment or with new evidence. So this book, I think, was published, the first edition was published, and when?
2012.
2012, and now almost 10 years. What, in your opinion, the strongest evidence in that you have that has been learned in the past 9 years?
Well, the book is about all aspects of science. It's not just about morphic resonance. And in the first edition, I argued there's a chapter on the nature of biological inheritance. And I've been arguing for years that genes are grossly overrated, because I think that genes explain the inheritance of protein, sequence of amino acids in proteins, but they don't explain all the form and instincts of animals, for example. They explain what proteins they make. And I think that morphic resonance underlies the inheritance of most of form and behavior. So genes are only part of inheritance. Now, it was very hard to get that point across, because in the 1980s and 90s, everyone was convinced that the Human Genome Project and genome sequencing would reveal the very secret of life at the molecular level, and billions and billions and billions of dollars were invested in all this. The Human Genome Project turned out to be very disappointing once it had happened. It's a technical triumph, but instead of enabling us to predict every detail of humans from their genes, it's surprisingly unhelpful. And in the new edition, I deal with what's come up since the first edition came out, namely the missing heritability problem. The study of tens of thousands of people's genomes have revealed that when you actually try and correlate the genes with characteristics like height or proneness to breast cancer or whatever, the genes explain less than 10%. In the best cases, it might be about 12% or 15% max, usually much less than that of the inheritance. Whereas we know that these things are 80% heritable, that much of these characteristics are inherited, but genes explain only a small part of it. And this is called the missing heritability problem. Well, I predicted this ages ago, and this has now happened, and it's widely accepted that there's a missing heritability problem. Part of it is explained by epigenetics, the inheritance of acquired characters, but only part. So
how epigenetics is a science of how different genes behave or act or activate in different scenarios. So two people have like the same gene, but for one, the gene is activated, the gene is turned on, and therefore he has certain traits, certain behavior, like higher intelligence, and in the other, the gene is turned off. And what determine on and off is determined by, for example, the environment. Yes, this is a concept of epigenetics.
Yes, good explanation, Roy. The genes are modified by methylation of the DNA, or by methylation or other changes to the histone proteins that bind to the DNA. So, usually these changes are wiped clean when sperm and egg cells form, but in some cases they're not. And so you can actually have a passing on of an inheritance of acquired characters, which in the 20th century was taboo in Western countries, although it was accepted in the Soviet Union. And this means that what was previously thought impossible is now possible, the passing on of inheritance of acquired characters, but this explains only a part of the missing heritability problem. So in the new edition of my book, I deal with, that's one issue that changes the argument. Another issue is that I have a chapter 11 is called Illusions of Objectivity, where scientists like to think they're supremely objective compared with everybody else. And what I pointed out in the first edition—
Scientist and Supreme Judge Court. They two things, they are purely objective.
Yes. Well, they thought that they thought that they were very, very objective, and I knew, and most scientists know, that actually they publish results very selectively. That you don't publish experiments that don't work, and you don't publish ones that go against your theory unless
the drawer effect, where you have many papers and you just and what doesn't succeed you put in the drawer, and what succeeds you just publish. And my field of expertise is deep learning, and when you say why did you choose this architecture, so I know because this is the only architecture that actually worked. So we scientists are not objectives in the scientific inquiry. It doesn't mean that they are flawed, but no. I think that, the pressure to publish is so hard, and it's so big, and it's so massive that people sometimes take shortcuts.
Well, you see, the thing is, in the first edition, I pointed this out. But then, just 2 or 3 years later, the replicability crisis burst within science. And this was headline news in Nature and Science and so on. It turned out that in biomedical science, up to 90% of published papers in top journals could not be replicated. In psychology, about 60%. The majority of papers in the most prestigious scientific journals cannot be replicated. So, and that's why it's called the reproducibility crisis or the replication crisis. And so I cover that in the new edition of my book, and that very much amplifies what I was saying in the first edition. But now, instead of it being people thinking I was just saying this and I maybe out of
you have empirical evidence.
Yes, this is, and I mean, I didn't gather this evidence. This is something that's now completely mainstream in science, that there is, and the reasons for it are now widely accepted, largely because of selective publication and putting the results in drawers. And also, the normal argument of people who defend scientism is that science is uniquely objective, firstly, because the peer review system ensures very high quality, and secondly, because it's all replicable. Well, it turns out that in practice, most people never bother replicating experiments, and if they do, until recently, most journals would not accept their paper for publication on the grounds that it's not original. So there was a systematic bias in publication, not only from the scientists themselves, but the way in which the scientific journals work.
I think that the originality issue was such a major one that you cannot replicate a study. Now, listen, I have so much to ask you, but I only have 5 more minutes. So with your permission, let me go to 2 final questions. I wanted to ask you about how morphic resonance deals with the Flynn effect or the Flynn-Lin effect about the growth of IQ in the 20th century, but I will pass on this and will ask you 2 last questions. Now, you had almost a lifelong friendship with Terence Mckenna, and you often quote him saying that modern science work on the principles that give me one free miracle, and I will explain everything from there. So first, could you please elaborate in 2 minutes about this great sentence?
Well, Terence was referring to the Big Bang theory, where according to the Big Bang theory, all the laws of nature and all the constants of nature suddenly appear from nowhere at the beginning of the universe. And also, all the matter and energy in the universe suddenly appears from nowhere. So the entire universe, all the matter and energy and all the laws that govern it appear from nothing in a single instant. And that's what he called the one free miracle that scientists believe in. And then they say, well, once we've got that, we'll explain the rest. It's just a matter of detail. So I think that was it was a very witty way of putting it.
Okay, and your first encounter, I think, is what's very amusing. I think that he like his first words to you was Dr. Sheldrake, I presume, yes?
Yes, that's right.
Okay, and second, and this will be my last question for today, what is the most valuable lesson that you take from your friendship with Terence?
Well, I think Terence, I don't know that there was a single lesson. Terence represented a kind of freedom of mind and inquiry and imagination. And it was really about the power of imagination, but not just random imagination, but controlled by wonderful gift of language and poetic speech, and an integration of psychedelic experience with the imagination and the way we see the world, giving a much expanded view of the mind and the nature of the mind and the nature of reality. And what this showed also was that when we explore consciousness from within, as we can through psychedelic experiences and through meditation and through many other experiences, then we find that it's much more than just our own brains and our own mental activity. We seem to be in contact with many other forms of consciousness beyond the human level. Telepathy and things are not spiritual phenomena, they're psychic phenomena. They're to do with, as it were, horizontal connections between people and animals, and the sense of being stared at. It's about connecting with the environment. It's not a spiritual phenomenon, and has very little to do with religion. It's simply a biological phenomenon. But these psychedelic experiences reveal the existence of other entities, other beings. Now, all religions have accepted this for a long time. Even very monotheistic religions like Judaism and Islam have hosts of angels and other kinds of spirit beings. And of course, Hinduism has devas and countless beings. And so I think what Terence and his work did was just open up the scope of our thinking about the nature of consciousness.
Different possibilities. But,
yes.
But you weren't just a duo, you were like a triplet with Ralph Avram. And you said, this is your book, your like summary of your conversations. And you said, I think that 3, and I tell it to my students all the time based on what you said, that like 3 was the best number because 2, sometimes the conversation stacks and 4 is too much, but 3 always get you like the enough fuel to continue the momentum. So if you can just like give me a few words on why do you think, in your opinion, 3 people to think science together was like the best number?
Well, you summarized it quite well, actually, Roy. I mean, we did experiments ourselves, not necessarily intentionally, but sometimes it was just me and Terence, sometimes it's just me and Ralph, sometimes just Ralph and Terence. And we found that these conversations, though interesting, never worked as well as when there were the 3 of us. However, Ralph's a mathematician, as you know, so he was very keen on the numerical principle of 3. When Terence so sadly died in the year 2000, Ralph and I, based on the idea 3 is the magic number, tried to find a replacement for Terence in our trialogues. We tried all sorts of people. We tried trialogues with a whole range of men and women that we thought might be suitable, and none of them worked as well as with Terence. So I have to say that one in 3ness in a dialogue is a trialogue is important, and I've found this in other contexts too. But these particular ones, their extraordinary quality depended very much on Terence and his freedom of mind, his wit, his humor, his ability to speak in a kind of bardic. He came from Irish and Welsh ancestry, and it was a kind of bardic gift, the ability for the speech magical speech just to flow through him. It was just amazing. So that was very definitely a part of it as well.
May God save his soul. And again, trialogues are more important and more useful than dialogue, special in scientific inquiry. Dr. Rupert Sheldrake, thank you so much for coming today. It was a mind-staggering conversation, so much to digest right now. Thank you so much for your time, for your scientific inquiry, and for your lifelong impressive work. Thank you so much.
Well, thank you, Roy. I'm very glad that you're creating an open forum for a discussion of ideas. It's really important. Okay, I hope you enjoyed the conversation as at least half of what I enjoyed, because I did indeed. Yes. It was a true pleasure. Thank you so much. Right.